Hello, welcome to this video. Today I'll show you how to segment the blood vessels and atherosclerotic plaques here in a mouse scan that was acquired with a microCT and a blood pool contrast agent. So this is the result that you would get after segmentation here. The vasculature here, and there's some plaques here at the truncus brachiocephalicus here. So here you can see the aortic arch, and these are the carotid arteries here, and here there's one calcified plaque here, and another plaque here is in the aortic arch. And I'll show you that in the microCT. I'll hide the segmentation. So if you look here, this is a calcified plaque. You can see it here quite bright. And if we scroll down a bit further, here's another plaque at the aortic arch. And the mouse was, I think, ApoE deficient mouse, plaque 6 mouse. Okay, so this is the result, but I'll delete this segmentation for now, and now we can do a segmentation here. So let's start with some thresholding. So the bones and the plaques are pretty bright. That's nice, we can utilize that. And then the blood is also bright, and if I change here the windowing, you can eventually, if I lower the values here, you can see the vasculature appearing here in 3D, eventually the blood vessels. So we can pick some threshold to do that, or we can try using a range. So let's add a class blood, and with this info tool button you can figure out the intensities of like the soft tissue. It's around 100, the blood is around 500 here, and then the bones are pretty high, like around even like 3000. And with this windowing here, you can nicely see also, you can use this to find a good threshold. So you can move the slider, and then at some point the vasculature appears, so we move it a bit higher. So here like a value of 800 is a good threshold to separate the bones from the vasculature. And then if you move it lower, here something like maybe like 400 is a good threshold to separate the blood from the soft tissue. So what if we apply here a thresholding, like a range, with like a lower threshold of 400 and a higher threshold of 800 to get the blood vessels? This works like this, and now we have a lot of stuff here at the bones. Why is that? Because if you look at the bones, the intensities here, there is a gradual transition from bright to the intensity of soft tissue. So this thresholding picks those voxels here at the edge. So this approach doesn't work that well yet, but what we can do is use a trick. So let's get the bones with a threshold above 800 here. Now we have the bone class here segmented. I can hide the blood, so now this is the segmented bone class here. And here you can see some plaques in 3D. And now we can use like a dilation of the bone. We could, well, let's try a coating. We'll add a temp class, and we do a coating. So we coat bone with 2 voxels, for example. And this temp class kind of takes away these annoying little voxels outside or close to the bones. Then we can hide this temp class, and now we have a segmentation here with the bones, and the blood vessels and the plaques are here segmented as bone. So we can now add a class plaque here, and we can make it yellow. And then we can use this picker here to fetch the plaques here. So let's turn on the CT and see where, so this is a plaque here, and maybe this could be noise also. And now we can delete the temp class, and so this is our segmentation here, and yeah, we can get the statistics here, the volume of the plaques, and you can get some some component statistics for the plaques, component statistics. So we have 3 plaques here, the volume, where they are, their mean intensity, and you can save this as Excel file and do further analysis. And while I'm here, I'll show you another feature here, because this is a nice blood vessel segmentation. And so you can select the blood as input class, and then here under the bone module, there's a tool, local thickness map of input class, and now this generated a local thickness map and loaded it as overlay. And if I hide the segmentation or just the blood class here, you can see the local thickness map, and this is fitting lots of spheres in 3D, and each value in the overlay represents the local thickness here, and it's a value in centimeter. So you can use this for further analysis of the blood vasculature, like the vessel diameters, for example. Okay, I hope this helps. Thank you, and bye bye.